one of the members brought a problem to me, the kit that does the speed controller. The speed controller, as you can see, has got very few components. It just works on the basis that you put in the voltage at one end, and what comes out at the other end depends on the setting you've got on this variable resistor. Very much like a 7805 regulator in the sense it's got an input and output. But instead of the ground, you've got an adjust terminal. So you can get feedback via these two resistors, depending on the ratio, depends what voltage comes out. So that's fine. And it's very simple to look at in terms of component count, hardly any parts to it, but it didn't work. So the first thing is, I usually say that most faults are visual. You can see the problem. You know, it's a dry joint or a component in the wrong place or whatever. In this case, there was two problems. One was visual, and the other, you probably wouldn't have do it by eyesight. So the first problem was that I got the meter on, put it in the bench, got on the meter, and got strange readings, and I very quickly realised that in fact the polarity was the wrong way around on it. And how did that come about? It came about because normally if you get a power supply like that one there, a wall wart, you can see, if I just come out the way a minute, there's always a little image on the body of the power supply that shows the barrel connections, the outer and the inner. And it tells you that the inner goes to positive and the outer is going to the negative. But for some reason, the one that was being used, this Panasonic adapter, when you zoom in on it, it's the opposite way around. The center of the barrel was going to negative, which is pretty uncommon. So it was a visual problem if you had thought about it. So that was easy. We replaced that with another power supply and it still wouldn't work. So the second problem was that the power was on, it kind of worked, you had a knob to turn, but instead of getting a nice easy progression of voltage coming out, it just suddenly wouldn't move and then suddenly spiked. And the solution was that the variable resistor that the member was using was one that's called logarithmic, because you can get two kinds of pot, and they usually tell you when you buy them, and that's adverts from eBay. It'll say on it, it's a linear pot, whereas that one there looks the exact same, but it says logarithmic pot. That slider says linear and that slider says log. So at the point you buy them, if you don't realize that there are two kinds of pot, you can quite easily buy the log pot instead of the linear pot. Or in this member's case, he had used a pot that he'd got in a job lot that had the correct value, but was a log pot. Why is there linear and log pots? Well, it's because log pots are used in audio applications, that your hearing isn't linear. In other words, if you get twice the amount of air movement, it doesn't result in you hearing it twice as loud. Over the years, mankind has evolved a defense mechanism against very loud noises. So the louder it gets, you don't hear it until it's really loud. So because the volume controls in an audio system have to use log pots for that reason. There's an example of the two. You can see on the left-hand side, that's what should have been in that kit. The bottom shows the amount of rotation of the knob from one extreme to the other. So if you turn the knob halfway around, you should get just half the resistance. So it's a 10K pot if you move it halfway, you should get 5K. If you move it all the way, you should get your 10K. The pot that is being used in this example, though, is a log pot. So if you move it half the way, you don't go up to 5K, you only go to 1K. In other words, there's a very small change until you're almost more than 2/3 of the way around. And then it starts to shoot up. Most of the pots you buy, some have, a very few will have stamped on it 10K log or 10K lin. Most of them don't. You'd only know that by checking with your meter. So if you're buying them, make sure you buy linear for model railway uses. And if you've got some you found in a drawer somewhere, before you fit it, check with a meter between one leg of the pot and the middle leg and turn the knob, and you should get an even change of resistance on your meter. Any thoughts on that? We're happy with that?